What's happening, everyone? You're back with Jono for another quick math lesson. Today we're going to rationalise the denominator when there are two terms down the bottom. So this is an extension of our previous video. So if you don't know how to rationalise a denominator with just one term, please have a look at that video. The most important trick for this is knowing how the difference of two squares can reduce a whole bunch of work. So this is the rule where we've got a plus b multiplied by a minus b results in the first term squared minus the second term squared. If you're not on top of that, I've got two videos explaining how to do it, so please check those out before we get into this. So here I've got 1 over 3 plus root 7. We want to rationalise the denominator, so it would be pretty easy to think, oh, if I multiply the top and the bottom by root 7, I'm good to go. But unfortunately, that makes the 3 multiplied by root 7, so we haven't actually done anything. We've just moved that irrational number across, which doesn't really help us out. So what we've got to do instead is multiply the whole bottom and top, not by itself, but by its conjugate. So what that means is exactly the same, but instead of a plus, we got a minus. So we're going to multiply this whole fraction by 3 minus root 7 on the top and on the bottom. Because we're just multiplying by 1 at the top there, we can very quickly throw this in there, and the bottom here is now a difference of two squares. You can FOIL this out if you want to. There is absolutely nothing wrong with that. It's just going to take heaps of time. So using that rule of the first term squared minus the second term squared, we can finish this off really quickly. The first term is 3. 3 squared is equal to 9. And then root 7 squared is equal to 7, so we just minus 7. To simplify this, we are left with 3 minus root 7 all over 2, and that's our final answer. We now have a rationalised denominator, or no square root on the bottom. So this can even happen if we've got a number on top of the fraction that's not just 1. So in this example here, we've got 2 over 9 minus root 11. So we're going to multiply this whole thing by its conjugate, which is 9 plus root 11. So this here is all multiplied by 9 plus root 11 on the top and the bottom. On top here, we're going to just expand the whole thing, so making sure we keep that 2 there, which is 2, 9 plus root 11. And on the bottom, we're going to use that same trick. 9 squared is 81. Root 11 squared is just 11, so minus 11. And then if I'm going to simplify this quickly, I've got 2, 9 plus root 11 all over 70. So you could expand out the top there, but because there's a times 2 at the front and an even number on the bottom, we can cancel these out straight away. So I'm going to cancel the 2 and the 70, which leads us to our final most simple answer, which is 9 plus root 11 all over 35. So again, this is a lot of work, but knowing that difference of two squares trick is easily the most important thing to being able to get these correct. We can even do it if we've got surds on top, on bottom, no matter where, as long as we're using that same trick. So here I'm going to multiply this whole fraction by root 5 plus root 3 on the top and the bottom. So I'm going to deal with the top a little bit later. So I've got root 5 bracket root 5 plus root 3 all over root 5 multiplied by root 5 is 5 minus root 3 multiplied by root 3 is minus 3. So here root 5 multiplied by root 5 is equal to 5 plus root 15 all over 5 minus 3, which is equal to 2. So I do realise that this topic is a little bit difficult, but as long as you're multiplying the top and the bottom by that kind of opposite pair, you're going to find these super cruisy. If you need any help, please check out some of my previous videos that go into these surd multiplications in a lot more detail. Thanks so much, guys, and I'll see you later.